Okay, in this video, we're going to be using this shell method to calculate the volume of a solid that's generated. Okay, so the region that we're looking at, R, is the region bounded by y is equal to x squared. That's this parabola here, the red one. Okay, we also have the line y is equal to x plus 2. That's this line right here. Okay, it's got a slope of 1, and it crosses the y-axis at 2 here. Okay, we're also bounded by y is equal to 0, which is the x-axis, so we have to stay above the x-axis. Okay, and we are taking this region that we have, and I'll color it here for us. This is the region we're looking at right here. Okay, we're taking that region and we are rotating it around this right here, this x equals 2. So this region here is getting rotated around this green line, this whole region right here. Okay, so to do this, to figure out what this volume is, we are going to use the shell method. Okay, so the first thing we want to do is figure out where these intersection points are. Okay, now we can kind of see them on this graph because this is a nice graph. We can see that they're at x equals -1 and x equals 2. But if you don't have a nice graph and you want to do this by hand, just set them equal to one another. So x plus 2 is equal to x squared and solve this. So let's move this stuff over here. Right, so we got x squared. When we move it to the other side, it'll become -x and -2 equals 0. And that will factor into x minus 2, x plus 1. And that will give you our two intersection points. This one, set them both equal to 0 and solve. So this one becomes 2, and this one becomes -1, which is what we saw on the graph here. Okay, so here's the intersection point, -1, and here's the intersection point 2. Okay, now we have the intersection points, which are going to be our limits on our integral. Now we can use the shell method. So let me write down what that looks like here. The volume using the shell method is the integral from a to b of 2 pi times the shell radius, and then we're going to multiply by the shell height. Okay, and in this particular problem, we're going to be with respect to x. Okay, that's because of the axis of rotation. Okay, is perpendicular to the x-axis, so we are dx is what we're doing. Okay, so we need to figure out what that shell radius is. Okay, so I'm going to draw an arbitrary rectangle here to show how we're going to find the shell radius. So let's say this is just a rectangle, no particular place. I'm just drawing it at a random point, and the top is bounded by this line, and the bottom is bounded by this line. Now I could have drawn it over here or anywhere. It doesn't really matter, but this is the shell we're going to use to visualize this. So imagine this shell being rotated around this axis right here. Okay, so what is the distance that we chose? Now this isn't an actual distance. I'm not looking for an actual number, but we'll just say that this distance from the y-axis to this shell is just x. We don't know what it is. We'll just say it's x. Now we know this is 2, right? This line right here is 2. So what's this distance between here and here? Okay, if this is x and this is 2, then this distance between here and here is 2 minus x. Okay, so 2 minus x to get this distance. If you add these two things together, you will get 2, right? The distance between here and here would be 2. So if you add these two things together, the x's would cancel and you would get 2. So this right here, this distance between this rectangle that I drew and this axis is going to be our shell radius. Okay, so let's go ahead and write that down. I'll put in the limits in a second. So the shell radius is going to be 2 minus x. 2 minus x is going to be our shell radius, the distance between here and here, 2 minus x. Okay. Now we need to find our shell height. Our shell height is going to be the top and bottom of this thing right here, right? It's going to be top minus bottom. So what is the top of that thing? Well, the top of that thing is x plus 2, right? And then the bottom is the x squared. So minus x squared. Okay. And this will be respect to x. And what are our limits? Well, our limits are the intersection points that we found. So -1, 2, 2. Okay. So you can work all this out. I guess I can go ahead and do that. So let's put the 2 pi out front. Here's the 2 pi. Here's my limits from -1 to 2. Let's go ahead and distribute this stuff. So 2 times x is 2x. 2 times 2 is 4. 2 times -x squared is -2x squared. Negative x times x is -x squared. Negative x times 2 is -2x. And then negative x times -x squared is positive x cubed. Okay, so this is all going to be with respect to the x. Okay, let's combine some like terms here. What kind of like terms do we have here? We have some x's here. Those look like they'll just cancel out completely, right? So they're gone. Positive and negative are the same thing. We can combine these two, a -2x squared and a -x squared make a -3x squared. So what we have not taken the integral yet. We're just cleaning up the algebra here. We've got an x cubed, nothing to go with it. We've got these two terms, that's -3x squared. Okay, and then we've got this plus 4 left. Okay, and this is all with respect to x. Okay, so x cubed minus 3x plus 4. So let's go ahead and take the integral of this. So the integral would be, here's my 2 pi still sitting out front there. Okay, so I'm going to get, this first one's going to become x to the 4th over 4. This next one will be minus 3x cubed over 3. We can cancel those 3's in a second, and then 4x. Okay, and we are integrating from -1 to 2. Let's see here. Leave the 2 pi out front for now. And actually, let's go ahead and integrate. Let's go ahead and evaluate. Evaluate our limits. So we'll plug in the 2. Leave the 2 pi out front. Here's a bracket, and here's my first parentheses to plug in the 2. So it'll be 2 to the 4th over 4. Let's cancel those 3's out. So it'll just be -x cubed. So minus 2 cubed. And then plus 4 times 2. Okay, there's the first parentheses. Now we'll subtract. We don't need another 2 pi because it's out in front of this entire thing here. Okay, now I'm going to plug in the -1. So it'd be -1 to the 4th over 4. Okay, the 3's are still canceled. So it'd be minus, and we're plugging in a -1 cubed. Okay, and then plus 4 times -1. Close that parentheses, close the bracket. Okay, let's continue to clean things up here. So equals, here's my 2 pi that's sitting out front. Okay, so 2 to the 4th is 16, divided by 4 is 4. Okay, minus, and then 2 to the 3rd is 8, so minus 8. And then plus 4 times 2 is 8, so those two things will cancel out in a second. Okay, minus, let's see, this is going to go positive because it's raised to the 4th power. So that's going to be 1/4. This will stay negative, but then it has this negative out in front. Okay, so this will end up becoming a plus 1 there. Okay, and then the last one will be -4. Getting close to being done here. Okay, let's go ahead and cancel out those two terms. Okay, so we get 2 pi times 4. Okay, what's this one going to be? Let's see, we've got 1 minus 4, which is -3. And then write this off to the side here. -3 plus 1/4. Right? So that's going to be equal to -2 3/4. Okay, and that's going to be equal to -11/4 if you write it as an improper fraction. So that's what I'll put in that parentheses. Remember, there's still this minus that's sitting out in front here. So minus a -11/4. Almost done. Okay, so remember the minus and the minus become a plus. So you get 2 pi, and then you have 4 plus 11 over 4. Okay. And then when you do that, use the common denominator. The common denominator will be a 4, right? So this will become, instead of a 4, it will become 16 over 4. Okay, so that's going to be 2 pi times 16 over 4 plus 11 over 4. Okay, which is going to be equal to, that's 27 pi over 4. So 2 times 27 pi over 4. We can cancel out this 2, and this will become a 2. So our final answer would be 27 pi over 2. And that's it. That is the volume of the solid.